Here's the input file for our program. It's currently a JPEG, so we have to convert it into a PPM file to be able to use it for this program. After we do that, simply enter the name, the command line argument, along with the PPM image's name. It generates three outputs, as you can see: a grayscale, a blur, and an edge detection one. Now, you're going to have to convert this into a PNG to be able to see it. So I've done that here. You can see the edge detection, the blur. If you zoom it in, you'll be able to see the blur, edge detection, blur, grayscale. Before we fork anything at all, we create all 6 pipes up front, 2 per worker. One pipe basically carries image data from the parent to the child, and the other carries the filtered result back. We create them all here before any fork call, so that when we do fork it, the children automatically inherit copies of everything. So here's the fork loop. Notice that we call fork 3 times without any wait call in between. This is to make sure that all 3 children are alive and running at the same time before the parent does anything else. So here it calls child process. Child process is right here. It's the function defined here. So inside child process, the first thing every child does, it closes all pipe ends that the child doesn't use. So it closes the right end for the in pipe and the read end for the out pipe. This is important because if we left, and then also, it closes the pipes for all the other children processes. This is to make sure that the pipes, basically if we left it open, the pipes would never reach the end of the file, and the parent would just hang waiting forever. Here we read the header from the file, and then we read all the pixel data. They use helper functions called read all. This basically loops through all the bytes to make sure that everything has been received, because a single read call isn't guaranteed to return everything at once. We scroll down here. This is the function to apply the filter based on what child the process is. So grayscale, blur, and edge, these live in filters.c. For grayscale, it's very simple. We just average the red, green, and blue channels for every single pixel and set all 3 of them to that one single value. For blur, we average the values of the neighboring pixels, and we set the center pixels, RG and B values to those averaged values. For apply edge, it's the edge detection algorithm. It's a little more interesting. We convert each neighboring pixel to grayscale, and then we apply the Sobel kernels in X and Y directions. The magnitude of the gradient basically tells us how sharp an edge is at that point, and we clamp 255 to that value so that it fits back into a single byte. Right here. Now, back in the parent, here basically we just close the unused pipe ends for the parents, so that would be the read end for the in pipe and the right end for the out pipe. We basically just write and read. We write the data to the children in 2 chunks, the header and image data. It's done using a struct that we've defined in filters.h. So width and height, that's the image header. So now here we get the results from the pipes. The parent just reads the filter results back from each output pipe, again using read all, to guarantee that all the bytes come through. Finally, it calls waitpid for each child. This is what prevents zombie processes. Every child that was forked gets waited on. And we also use ppm.c to help us write and read to ppm files.